think I want answered.
We are recording.
Yay!
Awesome. Okay, then welcome everyone. We're here together with Dr. Turak, who is a professor of engineering physics at McMaster University, and her research interests include micro and nanoscale systems, organic circuits, and issues related to energy and the environment. She's a former member of Spacesim and is here to talk to us about how her choices and activities in high school and university affected her career path and the work she's done in general. So our first question for you is if you could just quickly introduce yourself to the audience.
Absolutely. Thanks very much for inviting me, guys. I'm really excited about this because I have really fond memories of Spacesim, and it was a great time in my life. And so I'm really excited to talk to you all about it. So just a little bit about me. So I am Dr. Ayse Turak, and I'm an associate professor in engineering physics at McMaster. And so as we said, as Cesare said, my research interests are really around microelectronics and using basically organic semiconductors, which are plastic semiconductors, right? Sort of plastics that conduct electricity, as well as different functional nanoparticles, and for different kinds of applications. So we make sensors, we make solar cells, we make light emitting diodes, we make lasers, we make all sorts of different kinds of things. And that's really what we like to do. So the purpose is to make things cheap and easy and accessible and covering every surface with solar cells if we can. That's sort of my passion in life.
Okay, our next question for you is if you could, well, you have described your job, but really, if you could focus on your research that you're currently doing and how would it affect us in our everyday lives and why should we look forward to it?
All right, well, I'm going to share a couple of slides with you then, just to show you kind of an overview of everything. Let me see if I can do that here. I will try this. All right, can you guys see this? See my PowerPoint?
Yes.
Yes.
Great. All right, so I think I'm going to try to project it. Let's see if that works. Can you still see it, or is it gone?
It's still visible to me.
I still see it.
Okay, perfect. So here's me, right? So we work in, as I said, in organic, perovskite, quantum dot, different kinds of devices, and there's sort of two major areas, or four major areas actually, but two that I want to really highlight at this point is using these plastic conducting materials to make LEDs, solar cells, and lasers. So the idea is to make, LEDs you can use for lighting, you can use it for TVs, OLED TVs you may have heard of, this kind of stuff. Solar cells, it's about making energy out of sunlight, and the whole idea there is to combat the energy crisis that we're facing by utilizing the energy that's coming from the sun all the time. But we're also interested in making sort of sensors, and one of the big projects that we work in, for example, is using nanoparticles or nanostructured surfaces, smart surfaces, to detect acetone, and you can use that to diagnose diabetes, for example, from breath. So rather than using blood, you can use people's breath to sort of see if they have diabetes. And we also do a lot of work in what we call functional nanoparticles. So we make nanoparticles from liquid, basically, from solution for really cheap, so that we can cover lots of different areas. And we use that for batteries, for making water splitting, which is for hydrogen development, for making optical storage, data storage, like a hard disk, that kind of thing, as well as different kinds of sensors. And here's a picture, for example, of different kinds of nanoparticles, or the kind of nanoparticles that we make. And we learn about the nanoparticles so we can understand how they affect the sort of devices. So this is really the work that we do in a nutshell. And the reason I guess you should be excited about it, at least the reason I'm excited about it, is because the idea is to make the sort of, how can I say? So basically the idea is to make things cheap and accessible and flexible so that we can make it everywhere. Right? So if we could cover your entire house, for example, with solar cells by making a solar paint out of these kinds of functional materials, I think that would go a long way to alleviating some of the dependence on different kind of fossil fuels, other kinds of sources of energy. So these are the kinds of things that we're trying to tackle. We're trying to make the world around you easier to measure, make things really cheap, make it so that you can have it disposable in your house, in your hand. Right? So that's sort of what we're aiming for. I find that exciting. I hope you guys do too.
Okay, so now I'll pass it on to Josh to talk about career choice and your post-secondary path.
All
Sure.
right. So we're curious about how did you find a field that you were passionate about, and subsequently, how did you find a university that helped you get into this field?
So those are excellent questions, and I'll tell you a little bit of a story. So this is where I'm going to settle into my story time kind of thing, because I was involved with Spacesim, and you can imagine that I was really interested in aerospace and space science from a very young age, actually. And I used to read in the summers during high school and before that, like books of aeronautics, and I went to space camp. I was really like, I'm going to be a space engineer. I'm going to design airplanes. This is what I want to do. Maybe I'll be an astronaut. Who knows? This is what I went to university thinking I wanted to do. And and I had been, planning to be an engineer for a long time. And I went to Queen's for my undergrad. And part of the reason I chose Queen's was because they had a sort of a common first year where I didn't have to make a choice. But my mind, I was thinking, I'm going to go into Eng Phys. I'm going to end up in aerospace. This is what I'm going to do. And then one day in first year, I went to a chemistry class and it changed my life. So basically, there was a class called, we had a class called Chemistry of Materials. And there was sort of 2 weeks where a prof from the material science department came and gave lectures that were specifically about different kinds of material structures. And he started talking about things that I had never heard about before. And it opened my eyes to the fact that materials are kind of the essence of life, right? So without materials, you can't make an airplane, you can't make a computer, you can't make anything, basically. And so the idea that these were the fundamental building blocks completely changed my perspective, and I was hooked. So I immediately abandoned the whole idea of going into Eng Phys, and I picked materials. And in fourth year, I took a class, which was, because I was still interested in aerospace. I was still thinking, okay, I still want to do something aerospace-y. But, and I took sort of intro to aerospace, or aeronautical engineering, I think it was called, in fourth year. And on the first day, the prof asked all of us, which department we were from and that kind of stuff. And my friend and I were the only ones from materials. So we were like, oh, we're from materials. And everybody else was kind of from Mech or maybe from Eng Phys, that kind of stuff. And then the prof turned to us and said, all right, these guys are going to get excellent jobs in aerospace. The rest of you, not so much, because all of the stuff in the future is about materials development, right? And airplane design hasn't changed substantially in the last 40 years, really. But the materials that people use have completely overhauled everything, really, in terms of modern aerospace and modern aerospace design. So that was, this was 20 years ago, things have changed, but there have been some design changes after that too. So he was being a little facetious about it, obviously, he was joking a little bit, but that was sort of the essence of why I got completely obsessed with this area, is that, it allows you to apply the same knowledge to all these different areas. And you can look at all the different areas that we worked in. And though I said, I was talking about all of our microelectronics type things, that work has actually allowed me to come back to aerospace, back to space science, back to that kind of work, because we recently are working on a couple of really exciting projects. And even when I was in second year, for example, I ended up working for a scientist at the National Research Council. So I was a summer student at NRC for a year, or for the summer. And I worked for a scientist who's now a professor over at UTIUS, the U of T Institute for Aerospace Studies, because we were working in combustion and we were looking at combustion materials. And so he runs a whole combustion group looking at engines and engine combustion over at UTIUS now. So I never really left it behind. And then some of our projects now involve making lightweight power sources like solar cells for a high altitude balloon platform that's in the troposphere. So a student of mine started a company where they're making high altitude balloons. And so we're working with them to sort of incorporate solar cells into the fabric of the balloon to make it able to power itself over long times. And we're also working on a really cool project for remote power beaming, to control this balloon particularly, but you could also do it for satellites, that kind of stuff, using microwave lasers. So these are called masers. And then I'm also just in the last 2 years, we actually started another project that uses lightweight nanoparticle-based lasers that emit in the mid-infrared to make really cheap and simple optical space communications, sort of satellite to satellite or from ground to satellite, right? So even though I completely changed fields, I'm doing something completely unrelated, what seemed like at the beginning unrelated to aerospace, I still managed to worm my way back into my first love, right? I don't know. I guess in some ways the way I found a field that I was passionate about was being open to opportunities when they came along, right? And if something was exciting me, I didn't just say, oh no, I'm going to stick to what I thought I should do. I really was open to going where my excitement led me, and my excitement led me to materials. Materials led me over many years to be an eng phys, which led me to do a bunch of space projects. So I guess it led me there eventually at the end. So, yeah.
Yeah, that was a very fascinating story. Like,
Yeah,
I found it.
Go ahead.
I found it really cool how, even though you went initially at what first seemed to be a totally different field, you still got back to aerospace science. So that's like a really cool example how all the sciences are interlinked with each other, and you can like jump around between all of them and do pretty much whatever pleases you.
Well, exactly. I think the easiest way to be successful in science is to do something that you're interested in, right? And especially, it's really easy to get caught up in the back of your head thinking, oh, I'm supposed to do this, I should be doing this, this is what I wanted, I thought I should be doing, right? That should be doing word, I think, is the one that we should all try to get rid of. Because what you should be doing really is just doing what makes you happy. And if it's something that you're really interested in, sometimes you can find your way back, or sometimes you end up somewhere completely different. Before I listed off like 5 projects that we're doing that are space related, but 3 years ago, I wasn't doing any of those projects, and I was totally fulfilled by the work that I was doing. It was really amazing and interesting, and it's, every day I'm very lucky that I'm fascinated by what we're working on. It just makes me so excited every time I think about our work, and that's, I think, what is the secret to being successful in science. Is just you have to love it. It's a lot of work. You work really hard. You work long hours. You work a lot. But if you love it, then it's something that it's totally worth doing. You put all the hard hours in if you think you're going to get a payoff at the end. And then sometimes, like I said, you end up in this roundabout way back where I ended up back where I started, in a way. So it's kind of exciting.
You have a question, Aiden?
Yeah, you talked about how the general first year at Queen's allowed you to switch allowed you to more carefully choose into something you're interested in. How highly would you rate that you're now working, I believe, at McGill, if I remember?
McMaster.
I don't think McMaster. Okay, sorry.
Yeah.
That McMaster, I don't believe, offers a general first year.
They do, actually. But,
okay, sure.
Yeah.
Then how highly would
okay.
you rate the general first year as as an option, like when looking at universities?
So I would actually rate it pretty highly, partly because of my own experience, and partly because I'm at McMaster where we have one. But I think it's easy to get pigeonholed into, as I said, something that you think you should do, and then you find out that it's really not what you wanted or not what you thought it was or whatever. And having that option of trying out different kinds of engineering, I think, is really helpful. So the common first year, I think, is a really great option, but it's not for everybody. Sometimes people know what they want and they stick right to it. And, there are the great programs. Lots of programs are really great around Ontario, right? Or even in other parts of Canada. There are many, many great programs of engineering. and at places like U of T and McGill and Western and Waterloo, you have to choose going in for your first year, and people are very happy doing that, right? So it really depends. I think for me personally, it was a really great idea because it allowed me to make this change. But I for example, I was offered a scholarship to Carleton for aerospace engineering, for aeronautical engineering, and I turned it down to go to Queen's. But I think that if I had taken that one, I also would have been really happy because I love aerospace, I love aeronautics. I think I would have been able to enjoy that aspect of it. But I'm not sure if I wouldn't be where I am now if I had done that, right? So it's in an ideal world, I could go back and make that choice and see if I, at the end of the day, like this one more or that me more. But I can't. I only know me, and I like what I'm doing. So I think it's good. But I do think that it gives you a little bit more flexibility, right? Where if you're not 100% sure, or even if you are 100% sure, like I said, I was like, I am 100% going into Eng Phys. That was all I had planned for. And then, but this one class changed my mind. And that said, if you go into something like, say, engineering science at U of T, or if you go to Waterloo and do the nanotechnology engineering program, for example, these programs are also, you might as well call them common programs. They're interdisciplinary in the sense that you get exposure to lots of different types of engineering. And so, and you can streamline your particular interests after first year. So these are, even though these aren't technically common years, they're kind of broad engineering disciplines, right? That allow you to have lots of flexibility. And so I guess my answer is yes and no, right? So both yes and no. I think it really is something that you have to consider where you want to go and why you want to go. I went to Queen's, partly because I wanted this common first year experience, but partly because I didn't want to stay in Ottawa, right? There's the reason for turning down Carleton is I was like, I want to go away. I don't want to live with my parents. I want to live on campus. I want to have a real university experience. So I went to Queen's for part. So, it's not just the first year engineering being common that allowed me to pick Queen's, but it had an impact for sure.
Thank you for answering my very confusingly worded question.
No, it's fine. Well, thank you for listening to my long rambling answer that didn't really answer anything and said you should decide yourself. So we're even, I guess.
It helps a lot.
Great.
All right. I have a question for you regarding your post-secondary education, including your PhD focus and what you did after you got your doctorate. I know you talked a bit about it, but I guess could we have some more details?
Yeah, no worries. So my educational path is like this. I went to Queen's for my undergrad. I did it in materials and metallurgical engineering. I went to U of T for my PhD in material science and engineering. And then I did a postdoc. So after I did a postdoctoral fellowship in Germany at the Max Planck Institute for Metals Research. And so, there's a materials theme running through all these, as you can see. So I was very much a materials person. And then after I worked as a research scientist for about 5 years in this postdoctoral position, I came back to Canada and started a position in Eng Phys. So that's sort of my whole trajectory. And was there, other than just explaining it, was there a particular question you wanted to ask?
Yeah.
Or
What you got your doctorate and what did you do for it? Was it?
Oh, so my actual doctorate was in, so it was interface engineering in organic light emitting diodes. So I started working in these plastic semiconducting materials, particularly we were trying to make display technologies. So like I said, if you've bought a Samsung phone or you've seen an LG TV, these OLED TVs, that's the kind of stuff that we were working on. And when we started, they were a potential in the far future that one day we might be able to get to that kind of a device. So it's very gratifying to see in my, within my career lifetime, we went from making very, very minimal sort of displays to maybe one color kind of displays to these massive gigantic TVs you can buy at Best Buy, right? That's what we were working on at the time.
That's very interesting. I have a quick follow-up question. So you said went straight from your undergrad to your doctorate? You didn't need a master's?
So there are a couple of programs in Canada and more so in the States that have this. Mine wasn't exactly a direct entry. They're called direct entry. I started in my master's, but I transferred to the PhD after 1 year. So so it let me. I mean, it didn't. It ended up not saving me any time. The idea was that it would save me a little bit of time, but then I just took a little bit longer to do my PhD work. But you don't always need a master's. Sometimes you can have that option. And I knew I was interested in research. I didn't see any point in doing a master's and then doing a PhD. Often, if you're going to do that kind of thing, it's partly to try out different places. You know, like if you want to change, let's say you want to go from one school to a different school, you might get a master's one place and then go somewhere else if you want different kind of training. And sometimes people they want to change fields a little bit. But since I was interested in this topic and I wanted to go through it, I was happy with U of T. I went straight for the PhD.
So I know that you mentioned a bit about how your experiences at Spacesim helped create a passion for the aerospace industry. Guess I want some more details of like how did your experiences at Spacesim help you with your careers in the material sciences and some of your projects, such as the designing of these solar emitting diodes. Or let's
Excellent questions. So, so I really loved being at Spacesim. This is my jumpsuit. I thought I'd bring it out for you guys. You can see it. So here's my astronaut jumpsuit. You can see it here. These are our mission patches. Here. Right. So this is our mission patches. So I was an astronaut from in the 94, 95. Mission and I was in mission control for 95, 96. And let's see, 94, 95, I was very excited. I did one EDA and had 3 experiments that I was in charge of. And when I was in mission control, I was in charge of telemetry. So that was all the telemetry was me. And I have to say that none of that stuff really has helped me in my material science life. But I think the things that sort of space sim taught me was really about collaboration, right, about working with others, and how important it is to have a team environment. Especially when I was an astronaut, being inside the habitat for a long time with all those people, you really get into a rhythm of how to do experiments around each other or with each other or get people to do stuff. You know, you kind of trade off tasks to get everything completed in time because it's challenging. It also taught me a lot about how to do research in a way. Like how do you sit down and spend long amounts of time trying to get the answers to certain questions, but also planning, right? I mean, one of the things that about Spacesim, especially if you're going to do experiments in the habitat, you know, you have very, very limited time to do the experiments, and you have a lot of time to prepare for the experiments. And this definitely helped me in my later career because I ended up doing work at these large facilities in Europe called synchrotrons, and basically those are really high intensity brilliant light sources that emit light in lots of different wavelengths, but they're very, very high energy beams. And so you can use them to do materials characterization. So different kinds of, you find, for example, the crystal structure or the stoichiometry, the chemistry, what the components are, that kind of stuff. And these are really gigantic facilities, and they're very competitive to go and get time to work. And so, for example, you might get beam time is what it's called. So you get beam time of about a week or 2 weeks, and that's all you have to do your entire experiments that you need to do, right? And and so, you know, we would go as a team. We would plan our experiments for months leading up to those 2 weeks. We would go in there. We would do 24-hour shifts. Like we would basically all, you know, depending on how many team members we'd have, we'd trade off. You'd sleep when you can, do experiments when you can. Experiments were running 24 hours a day for 2 weeks, basically, which for any of you who've been an astronaut, that's exactly what it's like, right? Like that's the same life. So it's not like that life. It's not like the tasks that we did are necessarily what I took away. It was more about the skills that it gave me, the experience, how to go about doing this kind of thing, how to prepare, how to plan, how to do experiments, how to do something in a short amount of time, how to make sure I can finish my experiments before the time runs out, right? Like all that planning stuff. So those are the kind of things that I took away from that experience in Spacesim. And I used it in my postdoc life. I use it now, when we're planning experiments with everybody. So these kind of skills are things I think, especially in high school, there's really no other place where you have that kind of time crunch for doing a very specific amount of work, right? And so I think that was very helpful.
That was really interesting to hear. Like Spacesim really does give us all an opportunity to do like somewhat like actually pretty close to realistic lab experience. Like I know we get to do a few labs here and there in high school, but those aren't just the same. They're like on a much smaller scale, and we have a lot more assistance. So,
well, and not only that, do you have a lot more assistance, but also the kind of labs you do in high school are very prescribed. I mean, and that's even true when you get to university. In the first couple of years, you get a lab manual, you have a procedure, you follow the procedure, you get the results. Everybody knows what the results should be, everything is clear. But real life and research isn't really like that, right? And I feel like the experiments we did in Spacesim, I had to come up with my own experiments, things that we actually wanted to test, and we had an experimental plan, and then we had to execute that plan and then analyze the data afterwards, right? This is a lot more like real life. The experiments we did they weren't the most, I wouldn't say they were earth-shattering science, right? But it was a real experience of the actual scientific method, of what you really have to do in a real science environment. Because the one thing that I'm always trying to tell my students is that, we do experiments where we don't know the answer. We don't know what the outcomes are going to be. We don't really know what's going to happen. We have an idea, but until you do the experiment, you don't know what the outcome is going to be. And that's the kind of thing that I feel the sort of experiments that we set up in Spacesim were similar. We didn't know what the outcome was going to be. Sometimes we replicated experiments that had been done previously in actual space missions. Sometimes we replicated experiments where people did know what the answer was, but it was closer to that like it was real. It's a space sim, right? It's a simulation of life. So it was, in some ways, it was a good simulation of science and research that I would experience later.
yeah, I agree with what you said. So speaking about high school, I want to turn the mic over to Cesare to talk about like what more advice you have for us high school students to get into STEM. I know that you told us a bit about like doing what you want and being open to anything, but I guess Cesare has some more specific questions for you.
Thanks, Josh. And I would just also like to mention, if you ever have a question, feel free to raise your hand. So something I'm really personally interested in is what advice would you give for those going into university on how to like develop connections that would lead to opportunities? So this would be something like a summer internship or like tagging along on a research group, something like that. Like, how do we develop these connections so we can have these amazing opportunities in university? Because I know they're there, just how do we get them? Yeah.
So that's a great question, and so I'd advocate three things. And let's see if I remember all three of these things by the time I enumerate any of them. But anyway, I'll start with the first one. The most important thing, if you're looking to make connections with people, you really have to sort of do your homework. Find out about this person and what they do and what it is that why you're interested in talking to them, right? Because if somebody's going to talk to you, there has to be something in it for them too, right? And so if you go in with the attitude of, if you tell me everything about yourself and why it's interesting and why I should care, then it's never going to go anywhere, right? But if you made some effort and find out about them and want to talk to them on their about what they're interested in, find out what they're interested in, and sort of start on that space about where your interests meet, then you can start to build more of a connection with people. You know, it's, of course, this is not easy. I mean, this is hard stuff to do when you're a first year or second year or whatever. Going up to a prof is not easy. You know, even finding out about them is easy. But I think most people are really open to talking to you about what they're doing, as long as you're not sort of demanding something from them. So going to somebody and saying, I want an internship, is not likely to get you very far, right? But I can give you an example of what I did when I was looking for a postdoctoral position, is that what I said was, so I wanted to go to Europe after my PhD. I was very interested in going to Germany mostly. I really wanted to be in Germany. And so I found all of the groups that were doing the work that I was kind of interested in, that was similar to what I was doing, but was extending it in various different directions. And when I contacted them, what I said was, you know, I'm going to be in Germany anyway. So I didn't ask them to like pay for my flight or anything like that, because I was very fortunate. I had relatives that I was visiting anyway. So I'm like, I'm going to be in Germany. Can I come and see your labs? I'm very interested in what you're doing. Right. And I didn't ask them for anything. I didn't say I'm interested in a job with you. I didn't say any of those kind of things. I just said, I'm really interested in what you're doing. Can I see what you're doing? Can I come and experience it or whatever? And I found that to be quite effective in this way, where when you're not asking them to do something for you, they're more likely to respond to you in some way, right? And so what my advice is, if you were trying to work for a prof in the summer, for example, after you went into high school or into university, pardon me, the best thing to do is to approach them, ask them, you know, what they're like, ask them for a tour of their lab, for example, or ask them for some of their time, but then you give them something back, right? You can say, I'm really interested in doing this kind of work, or this is a topic that I was interested in. What do you think? You know, and some people may not respond very well to this, because especially with, you know, many professors have have a very fixed idea of what students can accomplish, and so it depends on how open they are to those kind of things. But I think that the more you do your homework and the more you approach them in a way that is not about what you can get, but what they can get out of from you, that it leads to greater success in getting those kinds of connections, right? And I would say that don't be afraid to knock on professors' doors, though, because if you ask them about their work, they'll start telling you. And in fact, it'll be difficult for you to get them to stop talking about it. They'll just start going on and on about it, and, you know. So those are the kind of things that I would really recommend. Is you have to. It's a value proposition, right? So if they're going to spend the time to talk to you about something, they have to get something out of it in a way. And so you have to try to find out what are the things that would trigger them to give them something that they want. So, you know, by being interested in their work is one way. By wanting to know what they're doing and how you can help them rather than how they can help you is I think a much better route of getting into something, right?
Okay, and as a follow-up, you mentioned landing a
Mm-hmm.
summer opportunity doing combustion research. Could you talk a bit about how you got that?
So that one there was a program that the NRC was running where you had to apply to get in through their summer research opportunity. I don't know if they still do it, but that was when I was in high school. When I was in university, they had that possibility. And again, the way that I got that opportunity is I had sort of researched the groups that I was really interested in working with, and I had reached out to them beforehand and asked them for a tour of their lab. So I had toured their labs, and so they already knew who I was, and they knew my name. And so when I applied, they saw my application, and then they picked me as one of the interns. And I told them I was going to apply afterwards, that I had there was this opportunity and stuff. So it's about, you know, it's about stacking the deck a little bit, right? You have to sort of. So I didn't ask them for an internship, but what I said was, I'm here, I'm interested in what you're doing. And then later when they saw my name, they're like, oh, I remember that name. That was that person who came and was interested in what we were doing. Let me pick them. They seem like they really are, you know, and then they saw all my credentials and it matched and that kind of stuff, right? So you kind of have to also have the backup of, you know, good marks and awards or whatever, like the things that are attractive to somebody, some evidence of Spacesim, extracurriculars, other things that you've done in that would make you sort of look successful. But the fact that you took that extra step of finding out about them, looking into what they do, seeing, making yourself known to them, means that when your name comes up in front of them, they're more likely to pick you over somebody else. Right?
Okay, thanks a lot. And the next question would be just, what kind of advice would you give in general to anyone looking to pursue a career in STEM and studying STEM in university?
So, I mean, my biggest piece of advice is the one I gave earlier, which is, do what makes you passionate. Do what you like, right? Not what somebody told you should do, or, lots of people will say lots of things to you about what you should be doing or what you can do or what your skills are, those kind of things. It's much easier to be successful in a particular area if you like what you're doing. That doesn't mean that you have to like everything that you do. It doesn't mean that every single problem that you encounter, that, for example, nobody likes to do homework, really. I don't like to solve problems. I don't like to do all the stuff that we're supposed to do in class sometimes, but the topic is what I liked, right? The things that the goal that it was leading to was something I was interested in, right? So you have to sort of think about, what is it that excites me? What is it? Where do I want to go? And how do I get there? And then you sort of go through the steps that you need. And I think the other really big message that I want to sort of say is that you should really believe that you belong there in these spaces, right? All of us get different kinds of perspective from people who are like, well, I don't know, or why are you picking that? That's really stupid, or you don't seem like the kind of person who likes that kind of thing, or why would you even bother? Like, these are the kinds of things that people will say to you all the time. And I think it's really important to sort of believe that you belong in that space, the space where, especially if sometimes people are telling you that you shouldn't. And your voice and your interests matter, right? Like, what you want to do, your perspective on things, you matter and you belong, and you should be allowed to be there, right? Everyone deserves to be in a space where they want to be. And so I think those are the key things, is sort of do what makes you happy and makes you feel excited, but also, I don't know, I'll pretend to be jargony and say, don't let the haters get you down, right? Like, anybody who's sort of bringing all that negativity, it's important to still remember that you belong in those spaces, and it's your space, right? And you can take it, and you deserve to take it. So.
Thanks so much. That was really insightful. So I'll pass it back to Josh to ask some more questions about your career.
Sure.
Yeah. So I found your career very interesting, and I think we all want to hear some more details. So,
okay.
For example, what were the highlights of it?
Oh, highlights. That's such an interesting question, because there's many things that were really great, good times. I mean, I would say that working at the NRC, for example, one summer was pretty exciting. Getting to go to Germany was very exciting. Going and doing these crazy two-week-long experiments, was definitely a highlight. Very stressful. I remember the first time I went. I don't know if this is a highlight, but this is, I guess, a very fond / bittersweet memory of mine. So the first time I went to one of these big international experiments. I was working like crazy getting my samples ready for, I think, a week or 2 weeks ahead of time, and I barely slept. I was like climbing all over the machine trying to get everything organized. And then, I took my samples, we went there, we put them on the machine, we ran the first experiment, and it didn't work. It was like a complete failure. Everything went wrong. It was terrible. I went back to the guest house where I was staying, and because we stay on site as well, because obviously we're working 24 hours a day, so you go and sleep in the guest house and come back to the experiment afterwards. And I went back to my room and I lay on the bed, and the bed collapsed underneath me, and then I started to cry. So it's just like, the world is against me. There's a real, and And then later on, I found out that the generator had exploded, and that's partly why our experiments didn't work. So it was the universe was really against me. But anyway, I picked myself up, and the next day we went back, and luckily they had fixed the generator, and the system was only down for a little while, and then I reran my experiments, or I tweaked various things, and then things started to be the way that they should be. But that was. I mean, I don't know if it's a highlight exactly, but it was definitely a memorable experience. And I think it definitely taught me that you can't really give up, right? Like sometimes everything's against you, but you just gotta push through. You gotta keep going. And somehow, if we had to do a lot of things to get everything back up and running, but eventually it worked, and we got some really nice results out of it. So these are the kinds of experiences that I think were real highlights. Another highlight of my career. I was in Germany for many years, and then I got this position in Canada, and but before I came back to Canada, I was offered another position, and McMaster was really very generous to let me take a year and go and do this other opportunity, because I got to go to Turkey. So I'm Turkish by birth, actually. I was born in Turkey, and we came to Canada when I was quite young. And it was always kind of a dream of mine to do science or be a professor or whatever in Turkey, because it's my roots, it's my heritage. So I was given an opportunity to be a visiting professor at Sabancı University for a year, and luckily for me, they teach in English, so I was able to actually teach in English. I can speak Turkish, but not quite to the level of being able to actually do science. Science is my personal life and my career life are so different, and so. I was very happy to have that opportunity to be in Turkey and experience that aspect of my life, and also, do science. And so that was a huge highlight, was being able to go there for a year and teach. And I taught some amazing classes. And then and then I think being at Mac over many years has been I don't know. I hate to say that there's a lot of highlights. I think I'm very, very fortunate in what I've experienced, and it's been kind of fantastic, I guess, in a lot of ways, and I really enjoyed it. Not that there haven't been low times. I mean, not every time is good. There was definitely a bunch of struggles. There were, like I said, sometimes the generator explodes and all of your experiments, fail, and things that you thought were supposed to work out didn't work out. So I've had a lot of those kind of times too, where we struggled for, when I was in Germany, for example, we were trying to solve a problem, and we're trying to answer some fundamental questions with our research, and no matter what we tried, we couldn't quite, the experiments didn't quite make sense. They weren't able to fit together in a model that we could develop. And it took us almost, I think, 3 years of doing various experiments here, there, coming back to the problem before we really felt like we had any kind of understanding to the point where we could move to the next stage of the project, right? So this was something that we should have been, that originally my boss was like, you have sort of, I don't know, like 4 months to finish this project because it's being sponsored by these people, and we just couldn't manage. And it took us another 3 years before we actually got the results that the company was interested in, and we finally managed to go back and like tell them. And they had moved on, but we felt very vindicated from a scientific point that this was really important. And I think that they did actually incorporate things later on. But that was one thing that was really nice about being at the place that I was in Germany, is that we did sort of applied research, but we also did some fundamental research. And so my boss was kind enough to allow us leeway, where even though this started as an applied project, it kind of turned into something more fundamental, because we couldn't solve their problem, but we were able to understand something about the universe. So it was sort of a win for science, not so much for that company. but yeah, so those are sort of the highlights, and also the challenges of a scientific career.
Yeah, the Germany story was really interesting to hear. So, like, in that story, you had like a pretty big challenge, but you managed to overcome it. Were there any other like twists in the road throughout your career that affected your progress? So, can we a bit of details about them if you're willing to share?
Sure. I mean, there have been lots of twists in a way. Like I said, on paper, I do have a very linear career, right? I went to undergrad and then I went to grad school and then I became a postdoc and worked as a scientist and then I became a professor, right? So it's this very, it looks on paper to be quite linear. But you know, I spent a lot longer in Germany than I had intended. Right? I was hoping to come back to Canada after the standard 2 years, sort of 1 or 2 years as a postdoc. It didn't really work out that way. I ended up doing, you know, I was very fortunate that I got a fellowship and was able to extend my time. And then I was very fortunate to get this position in Canada. But you know, there were a couple of years definitely where, you know, like I said, we were working for years on a project that was going nowhere, which meant we weren't really publishing anything. And in the world of science, if you don't publish constantly, then you fall behind, right? And that's true in science and engineering and in academia generally. And so there definitely were times where, you know, I'd be like, oh my God, you know, my career is going nowhere. I don't know how I'm going to succeed. I don't know what we're doing. Like none of our hypotheses are working out. Our experiments aren't giving us what we want. And so, you know, those are dark days, but you overcome them by, you know, sometimes you change directions. We started doing some other work on the side because this project was going nowhere. So we started working on something else. And actually it's very interesting. One of those side projects that I was pursuing just because I was like, well, I wonder if this would be interesting. It really became super fruitful. And now it's a direction that my research is taking at McMaster that's completely different from where I started in a way. You know, even though it's within the same area, if we hadn't done that side project, a lot of this work with the nanoparticle sensors and the different kinds of nanoparticles that we're making really cheaply and easily wouldn't have happened because I was doing a completely different synthesis method. We were doing different kinds of things. And it was really, again, a chance encounter with a colleague who was like, oh, well, we know this technique and it's really interesting. Would you like to learn about it? And those were my colleagues in Turkey. So that's why I went to Turkey to sort of learn more about that technique. And then I brought that back to McMaster. And then it really is the basis of the work that we've done for the last 10 years, right? So you know, it's one of these things where when I look back on it, I don't see it as being a twist or, I mean, it was hard at the time. There was lots of adversity, but at the end, it's kind of what got me to where I am now. So I look at all those times as being great opportunities to try something new, to go in a different direction. I mean, in some ways, it's even the same thing when I first came to Queen's with this sort of vision of being an aeronautical engineer. And sometimes these opportunities, when they present themselves, if you take advantage of them and you're open to changing what you're doing to adapt to the situation, you find that at the end you kind of become either successful or maybe where you thought you should be, but that wasn't the path that you thought you were going to take, right? So that's definitely partly what happened to me, I would say.
Yeah, so that is very interesting. So I guess in STEM, a lot of the challenges, like once you get overcome them, they turn into opportunities. And like what I'm starting to see is that you have to kind of go through some challenges to get to these opportunities. If you aren't willing to challenge yourself or push yourself outside your comfort zone, you'll never get to these opportunities.
Absolutely. You know, one of the things that's very important to remember about science and about research, right, is that the things that you're doing are supposed to be challenging, right? Especially if you're doing research at the cutting edge of something. You know, it's not something that that is, if it was easy, the people would have done it already, right? So the reason you're doing it is because it's something new, it's something challenging, it's something that people haven't done before. And if it's that way, then there have to be challenges that you have to overcome, right? There have to be things that you don't know how to solve right away. You have to work through these different things. So I think you put it very well, right? Within every challenge is an opportunity, but you have to experience the challenges before you get to the opportunity often, right? It's sort of a process.
Yeah, so Dr. Magwood, you have a question?
Dr. Magwood, you're muted.
This is the constant
always happens.
part of Zoom.
It's much better. I'm wondering if you have any thoughts from your current perspective on what you might have wanted to see done differently in Spacesim back when you were there.
Oh, that's a good question. Oh, I hadn't thought about that. I have to say, I really enjoyed Spacesim in the way that it was, the way it was organized at the time. I don't know if things have changed really in the way that it was organized. When we were doing it, we still had the exchange with the high school down in North Carolina, which was very exciting. And
we've been trying to bring that back as a group. Unfortunately, now isn't the greatest time for that, but we're really working towards it.
Yeah. So I would say that obviously this year is clearly not the year to do that, but having those connections to other people and having that exchange opportunity, I think was really fantastic, and I would encourage that to go ahead. Though I'm not sure if I would necessarily pick that same school in North Carolina, but having that kind of experience, I think, and maybe having it with more groups around if possible, even within Canada, right? I mean, there aren't that many space sims around, but I think it's a system that could spread out to other schools. I don't know, you guys know, I haven't been following, I have to admit, the space sim sort of universe since I left Elizabeth, but
seems to have contracted more than it's expanded.
Oh yeah. Well, I'm not surprised, unfortunately. I mean, one of the other things that we were very fortunate at the time, I don't know, where is your habitat? Is it still at Ottawa Tech, or is it?
Back at Ottawa Tech, so it moved afterwards after you to the Media Center on Brunson, and then moved back to Ottawa Tech. Moved back into the same room.
Really?
We had some stuff written on the blackboard from 3 or 4 years in the past.
I have fond memories of Ottawa Tech.
We moved since to the opposite end of the building.
Oh, okay. So that space, I think, was not the great. I mean, the one that we were in was not the greatest, but it did give us the opportunity to have sort of an interesting space. I think one thing, and this is just from, I'm just thinking off the top of my head, it would have been nice to have different levels in the habitat. Like, we were all in one flat area, and that was great, but that's also not super realistic to a real space habitat, and also it's a little confining. I mean, as I guess, again, we're simulating space in which things are confining, but I think having multiple levels would allow a little bit more privacy in a way for the astronauts, because that's one of the things that I was the most challenged by being an astronaut in those years, was the fact that somebody was listening or looking at you all the time. And you couldn't get away from it, obviously. I mean, obviously Mission Control has to pay attention to you, but I feel like if you could at least get away from the other astronauts by, going to a different level, that would be at least like a psychological sense. That would have helped a little bit. I think that was something I found. Mentally, it was really hard, Mm-hmm.
We actually thought about that in our current habitat when we were designing it.
Oh,
and
cool.
The school board offered to try to accommodate 2 stories, but it seemed like it would be a big engineering challenge to actually make it work.
Yeah.
So in the end, we stuck with a single level. Yeah. But we had 4 compartments, I think, than you had at the time.
Oh, that's good. I remember I was involved in the habitat redesign at the time in 95, I guess, when we were doing it then, or the 95, 96 year, we sort of redesigned the habitat, and I believe that and because I was in charge of the telemetry during my mission control year is why they called the Ayse Drive the Ayse Drive, which I know you guys pronounce it differently, but the way it's written is still my name. But I think that was the reason. I was very honored by that and flattered when I found out that they did that.
Yeah, we still call it the Ayse Drive to this day. That's how we pronounce it. I think
good.
I'm sure you'd be quite interested. One of the initiatives that our group, I'm one of the commanders, one of the club heads this year, along with Cesare, Blakely, Murray, and Aiden, who are all also on this call, I believe.
Excellent.
We are because we can't be doing a lot of the active things that normally take up a lot of our time during the club's timeline, we are working on looking into the club's past and just other aspects that people are interested in to try and find ways that we can improve things going forward. I don't know if you've ever visited our wiki. We have a wiki where we've documented as much of Spacesim's past as we can. Of course, there's a lot of things that are long before any of our times. I joined the club in 2017, and I am one of the club's oldest members right now. So we're really looking to get people writing down things about the club's past, and then we have a project where we're writing proposals and ideas for how we can change things that we didn't like in the past, or bring back things that were good in the past and we've since stopped doing.
No, that's really cool. I have been to the wiki because I can't remember if I Googled myself or there was somehow I became aware about the Ayse Drive. And then it led me down a rabbit hole of finding the wiki and everything. And even when I came back to Canada, because I mean, when I was in Europe, really, I had it wasn't on my radar. But when I came back to Canada, I think I either looked it up or something happened where I sort of found out about it and went to the wiki. And in fact, I think I gave a little bit of detail for the wiki about what I did. So I have a little blurb where I wrote to whoever was running the wiki then. I found this email, so I thought I'd pull it up in 2012, saying I was a member here. This is what I did. This is when I was that kind of stuff, just to sort of to give that kind of thing. So I am aware, and I'd be happy to share my recollections. I have to admit that apparently in 2012 I still remembered what I actually did, which is great. Now it's at the 10 years on, it's getting a little fuzzier. I have to admit, it was a long time ago now. It was it's almost 25 years ago, and so it was. I mean, I have such fond memories of it that all I remember are like the really amazing parts. I remember the chemical toilet. I remember going on an emergency EVA because we had to. I can't remember. I think the airlock had a problem. One of the astronauts got a chemical burn from dry ice. I remember, and we had to do an emergency coupling. I think we had an emergency. Doctor basically like came from Earth to the habitat, and we had to do the whole thing and have an EVA to sort of get him to some treatment and stuff. Like, I remember all these amazing things, but some of the specifics, like which experiments we did, it's gone, right? Like the disasters that were planned by Mission Control.
Any and all experiences they're worth writing about, because like we have articles written about the most mundane little things. They're the most important parts of the club, really.
Absolutely.
Our science reports can speak for themselves in terms of what we've done, but only by keeping the sort of memory of how the experiences that our members of our club had and why people really want to be part of Spacesim are really the most important part of the club's culture, which is what keeps us going.
Absolutely. I mean, from that perspective, I think one of the things that I really appreciated in my time, and the reason I loved it, is our mission Commodore was Dr. Pritchett at that time. So it's a long term. I think he's been retired now for many years from Lisker. But he used to let us use his office as our clubhouse, basically. And so whenever we were so we never sat in the halls. We always sat in his office. Like, we took his whole office over. He never even used his office. I think
we still do that. That's great.
We still do that. There you go. Yeah. So I think that kind of thing was awesome, right? Like, that was the sort of thing that really made the club. The fact that we were all so together and so tight knit and so sort of like. Interested, and like, it was, to me, it was this incredible safe space where you could just be who you want to be and just be, I don't know, be there. I think that was awesome. So I'm glad to hear that you guys are still doing that, because there's nothing better than sitting around in that office and having lunch, or sitting around reading or working on assignments. And it's interesting. I would say that that sort of culture, that camaraderie, that togetherness, that sort of showing up at the office and sitting there for whenever I had a spare. That's the kind of thing that I also see in our students at Mac. So, you know, EngPhys is a very small department relative to other engineering departments at Mac, and we have our own little like lounge where the students hang out and people just drop by, and upper year students help the lower students with their, you know, there's like an impromptu tutoring thing that goes on there, and so the same kind of mentality, this idea of having a space that's a shared space that we can share and come together about the things that we find cool and geek out about and do calculations and plan telemetries and like do all that kind of stuff together, I think is really one of the things that drew me to the club, and is something I think when I look at why people come into EngPhys, for example, it's that culture. It's the fact that the students and the professors are all in it together. And, you know, I always felt that way with in Space Sim. It didn't matter if you were in grade 9 or grade 10 or grade 11 or, you know, if you were whatever, we were all Space Sim together. And even our Commodore, right? I mean, he was, God bless him, he was fantastic, but he was definitely one of us, right? He was the sort of king of the geeks. This is how we always felt about things. And you know, we were super proud. We were proud of it. And I think nothing in my life made me as proud as being as part of Space Sim. So you can see I was so excited. It was Jordan Melzer was the one who told me that he I guess I think he told you, Cesare, that you should talk to me. And I was like, oh, I'm so honored. It's so great. I love Space Sim. I love those times. So he and I were in Space Sim together in our high school years, right? So we're still friends now. And, you know, I get to see him and his wife and his beautiful kids, and they come and see our family. And, you know, like those are lifelong relationships that you can forge. So.
Okay, so we have hit the 1 hour mark, and I'm just wondering, is there anything you'd like to talk about that we haven't touched on yet, or we just talked about in a bit of detail?
Well, I mean, if you guys are willing, I'd love to hear a little bit more about your mission and what you guys are doing, and how you dealt with COVID, but also just in general, how things are these years.
Okay, yeah, so I've been playing this stuff. So this year, since it's online, we actually just got a server like up and running, and I think Dr. Magwood posted yesterday, he changed our software a bit, so now we can like run it over a VPN. So we're soon going to be doing like mini missions and all of that once again online, and that's really exciting. So the plan for this year is that we're not going to simulate a mission to space, but we're going to basically launch a satellite. And so we started off, I wanted to just think, like, I've read about an old workshop we used to do where we designed satellites. So we basically did a ton of research on satellites and came up with a shopping list of parts. And then the next part was to just, okay, you have a list of planets we're interested in, one that many in the TRAPPIST system. And basically this year we want to look at exoplanets, right?
Mm-hmm.
Places that could support life. So we're planning to create a satellite and launch it. And, you know, because we're not going to do one simultaneous mission this year that takes 7 days, it's going to be something we come back to each Friday work session. So it's almost like simulating real life, how we control rovers and satellites. You know, you give it an instruction and you don't hear back from it immediately. You know, there is a time delay, so it's going to be kind of simulating that aspect. And the plan is basically to prepare for next year's mission by doing this, and we'll just have even more info on what planet. We're basically, by sending these satellites, we're going to determine which planet we want to travel to next year, hopefully on an in-person mission.
That's awesome. Do you have a target planet in mind for the satellites, or?
We have many. I have a list. I'll bring it up. So yeah, we want to send one to the TRAPPIST system. Another one was Lucian B, and I forget our last satellite.
If I can jump in on explaining it. So what we did is, I'm guessing you probably knows that exoplanets, at least for us, are very, very lacking in information.
Yeah.
So what we did we used a bit of pseudoscience to fudge with what we were doing, and we looked at, there's a software, Blakely would know the name, where it generates planets. And we looked at that, and that was our way of going, is this something from what we know? Because the people that made the system more or less were like, this is the best estimate. And we ran with that as a baseline, and that's how we determined using also like distance, the estimated temperature, and that's how we decided, is this planet realistic? And now we're going to do, the simulators are going to come up with data, and then we've made custom satellites for each one using our shopping list. And then we're going to look at them, and then astronauts this year will then say, we're doing this one. And then next year's plan is to run an actual mission to that destination using pseudoscience, as we don't actually know.
The last planet was Epsilon Eridani, so we're sending one to Lucian B, one to Epsilon Eridani, and one to just the TRAPPIST system in general. And we also plan on landing our satellite and having it turn into a rover almost. Yeah. Okay, and we made our own like little command programs, so just like little commands we could use to send, and we're just going to put them in text file, and basically a week later we're going to hear back from the rover. So in that week, the simulators are going to come up with whatever data the rover had to produce.
That's great. Yeah, that's very creative. I really like it.
It might be, yeah, you can think of it similar to the Chinese mission to the moon, basically, where we had the HAB and then Ayse, right? And basically, Ayse will just stay in orbit of the planet. Then the HAB, you know, attaches, it lands, and that'll be our satellite, our rover, and it's going to launch back up and dock to the HAB, and the HAB will bring it to the next planet. That's
awesome. Cool. Wow, that's very exciting. Good for you guys. That's fantastic. I really this year has been very challenging for everybody to sort of find new ways of doing things. But I'm glad that you guys definitely rose to the opportunity and did something pretty cool. So that's, I mean, you know, if we were doing it the same way every year, you get kind of caught up in a rut too. And as nice as the habitat is, this kind of is a cool way to explore a new way of exploring, right? That's I think it's very creative. So good for you guys. Congratulations. Okay, are there any other questions? I think Jamie, you still have your hand up.
I'm reading nice, but Jamie doesn't like it at all. But the local.
That was a mistake. Sorry.
That's no problem.
So does anyone have one last final question they want to ask?
I've got a sciencey sort of question related to your.
I'm on the spot.
These nanoparticle sensors that you're talking. Are there any way to integrate those if you wanted to use them to make some sort of photo chip for a telescope, for example, and get better resolution? Or are they just too small and? I mean, I would imagine that they're not really attached to a circuitry network now. They're just painted onto a surface.
Yeah, I mean they are attached to electrodes because the network within which the nanoparticles are conductive themselves, and so you need to access the outside world. But there's two different approaches you can take. One that's electrically driven, but also one that's optically driven, where some of these particles are absorbing in various wavelengths, and they can emit at other wavelengths, and so you can convert light, for example, right? So those are part of the kind of things we do for the sensing, is it can sense different kinds of light. So people have done nanostructured sensors for telescopes before that I've heard of, and partly they can increase particularly in low light environments, you can actually increase the amount of light absorption by using a nanoparticle structure rather than just flat plates, for example. So there have been some work in that. We don't do that particularly, but I know people who worked in that area for sure. And this is part of the challenge of nanoparticles, is that they are individual and they exist kind of outside of the circuits, and making contacts with them is one of the biggest challenges. And that's a lot of some of the stuff that we work on is, how do you make really effective contacts? What kind of a mesh network do you need? Can you use traditional types of structures, or often we have to engineer the contacts as well as the materials, and simultaneously to get effective, the effective charge collection that we need to get the sort of signal response, for example. So so these are definitely part of the challenges, but there is work in this area for sure.
Thanks. We were talking about stuff like this in our Earth and Space course this year.
Well, that's cool. I think if I can find the paper that I'm talking about where they've increased particularly for radio telescopes, I think they had included some sensors. I'll see if I can dig it up and I'll send it along. But it may take me. I have to look and see if I can find it. I'm not going to make any promises, but maybe if I can find something, I'll send it along and see if it's something that you guys might be interested in.
That'd be great. Thanks.
Thanks so much, Ayse. I'd like to thank you on behalf of all the club. So many of us are interested in pursuing a career in STEM and or like engineering, physics specifically. Myself, since 7th grade, I was just obsessed with aerospace, and like I knew I wanted to do that in university. And it was really cool to hear about your experiences, and not just from anyone, but a former Spacesim member. It's incredible. Also, like the one that Ayse drives are named after. We all know your name.
I know.
It's really awesome. Thank you so much, Ayse.
Well,
it's really awesome.
No, thank you guys. Thank you guys for the invitation, and it's my honor. It's my pleasure because I love Spacesim. I love my time in Spacesim, and I hope that you guys are getting as much out of it as I did. I think it was very formative for me in high school, and I'll share one last story before we head off. Is that I came to Lisker actually at the beginning of grade 11/12 because I grew up in Alberta actually, and we moved to Ottawa when I was in high school, and I left in grade 10 and ended up in grade 12 when I came here, and it was years that we had grade 13 and everything. Everything was very different than it is now in high school. And you can imagine if you start a new high school or a new school in the middle of the term. I started in October, I think, if I remember correctly. It's very jarring and weird, and you feel out of place. And Spacesim was my home, and it made me feel that Lisker was a place for me. And so, I really feel very connected to Spacesim, and I think that it's a really special place, and I hope you guys are really enjoying it. And even in these times when you can't all lie together inside in that room, I think those are the kind of things, this sort of togetherness that Spacesim gives, and the support and the safe space that it allows you to be who you are, is really what makes it special. So I'm very, very honored to be asked to come and speak to you guys.
It's an honor, and definitely an environment for a club that we are working very hard to maintain, even in this difficult time. It's more important now than ever to have a good community where we can all be together.
Absolutely, and good for you for keeping it up, and I wish you the best of luck. And if there's anything that you guys need from me, please feel free to reach out. I'm, like I said, I'm a proud alumna, and proud I'm really happy that it's continuing the way it is. So
thanks so much, Ayse.
Thank you very much.
All right.
Yeah, thank you.
Bye. Bye, guys.
Bye.
Thanks. Bye-bye.
Nice to meet you. Have an excellent day.
Still, I was able to do it on the bed.
Yeah, that went well.
That went very well.
Yeah, I really liked the flow of the conversation that we were able to develop.
Shall I stop
And then she
recording?
left and just immediately
probably.
she left and then immediately the meeting side
Yeah.
just got cut in half.
Nah, it's fine.
People are cool though. Yeah, she's cool. I like her.
Josh, can I say one thing